Everybody, in today's lecture we are gonna talk exactly about port addressing, IP addressing, and MAC addressing, how they work and how they are related to each other. This is the first section. In the second section we are gonna talk about the TCP IP model and how is it different from the OSI model. Then compare the protocols that are used, map these two models to each other and study about the protocols that are used in each layer. After that, we are going to talk about some networking devices and some basic commands that you can run in your CMD in order to configure and find out the parameters of your network that you are connected to, or in general connected to a website or web address or whatever. So all these things are going to be discussed in this section, but this subsection is going to be dedicated to only addressing. So if you remember from the previous lecture, we talked briefly about like IP address, MAC address, port address, but we talked about them individually. We didn't link them with each other. So when you have a computer that wants to send some data generated by certain application. When I say application, it means software run on your computer or on your PC, or like Skype, Microsoft Teams, any software that can be connected to the internet, or TeamViewer, any of these softwares. So this generates some data. This data needs to be transmitted over the internet. So what's the procedure? So basically at the beginning, you generate this data, which is in human language. You convert this data to ASCII code, and then you compress this data, and then you encrypt it, and you do some source encoding in order to reduce the size of the data. After that, once the data is ready at the application layer, as you can see here, once the data is ready at the application layer, it passes the data to the transport layer. Now the transport layer has also many functionalities, but one of the key things that transport layer adds to the packet is the port number. So basically, it adds to the header of the packet the port number. So if you want to see the port number of a packet that's being communicated over the internet and you have Wireshark software, you can find this detailed information from the traffic going forth and back in the computer network, whether in cables or in wireless. So this is the transport layer. One of the things that it adds regarding addressing, it adds the port number. The port number is just number that's associated with a certain application. For example, Facebook, in order to communicate over the internet, has certain port number. WhatsApp has certain port number. Skype has certain port number. If you want to send an email, there is specific port number. If you want to block a user, if you want to prevent a user from sending emails, you can block this port number and the user will not be able to send any email. Although he can access the internet, although he can browse, do Skype calls or anything like this, but he will not be able to use just that specific application because the port number is blocked. So this is the importance of port number. Each application, each software that can be connected to the internet has a specific port number to communicate over. So the port number determines the process in your operating system. After the port number is added to the data, it passes this data back. It passes the data to the network layer. Network layer, what the network layer does, it just among the many functionalities that it does, it adds the IP address of the destination, and then IP address, source and destination, always regarding the port, also source and destination, MAC address, source and destination. And once it adds the IP, it passes the data packet to the data link layer, and the data link layer adds two things. First, it adds this thing that's colored in red, which is the MAC address, the physical address, and it adds something in gray here, as you can, T2 here. This is for control purposes. For example, in MAC layer, data link layer, we call this cyclic redundancy check. So cyclic redundancy check is a method that can be used in order to detect if the packet is received correctly, successfully or not. If the packet is received successfully, then move the packet forward. If it's not, then retransmit the packet again. And then you send this packet once you add the MAC address and CRC and pass it to the physical layer, to the antennas, and convert bits. Basically, after the physical layer, you start dealing with bits, and these bits gets converted to electrical signals. Electrical signals then electrical signals get converted to electromagnetic signals using copper cables or antennas, and then it propagates. Your data will be like a wave in the air or a wave in a cable, and your receiver is responsible to reverse this process back. So at the receiver side, it's the same, but in reverse. If MAC address and cyclic redundancy check, IP and port, and then you get the useful data. So in summary, the transport layer, in the transport layer, the source port number and the destination port number are added, both of them. In the network layer, the source IP address and the destination IP address are added, while in the data link layer, the source MAC address and the destination MAC address are added in the header, and error control related things are added to the end of the frame. This error control related things, I may ask you about why we need to use it. It's something that's added to the end of the packet. What's this something? It's sequence of bits. These bits are used to detect if there is any error in the packet. That's why they call it cyclic redundancy check. If an error is detected due to impairments in the channel or due to malicious hacker or attacker who's trying to manipulate the packet, then once it detects that this is not the packet, the information sent is not correct, there is an error due to environmental issues or due to an attacker trying to manipulate the packet, it just detects and asks the transmitter to resend the packet again. Then the entire content, after converting this to a frame, the entire content is converted to zeros and ones, which is the language that the computer, the CPU in the computer can understand. And after it gets out of the CPU, out of the microcontroller, and you want to send it, then it has to be converted to electrical signal. Because this is how you convey zeros and ones. Zeros and ones by themselves cannot move, cannot go anywhere. Yes? Zeros and ones. But like with electrical signal, you give them petrol, you give them like soul. They start moving with electrical signals until they reach where they move through. If you know the physical layer, you get from filters, power amplifiers, diodes, and then until you reach the RF chain, which is the radio, until you reach the antenna. Once the electrical signal, which is the current, reaches the antenna, it gets converted to electromagnetic signal that can propagate through the air. Why? Because electrical signals by themselves cannot travel over the air. And bits by themselves cannot travel through cables. You understand me? They don't have energy, they don't have like soul, they cannot move. So then the entire content is converted and so on. After you transmit it, it will be received at the destination computer. Port addressing related things are done in the transport and IP are done at the network. Let's give an example here regarding IP addressing and MAC addresses. Let's say here we have a computer, we have call it the sender here, and generates data from, let's say, Skype. And the data here is at the upper layer. Then here assume since we are here focusing on the network level, we are not gonna deal with the port number because here we are not showing which application is being used. We just focus on the IP and MAC. So the data here at the network layer gets an IP from the network layer, an IP address, destination, and source are attached to the beginning of the packet, and then passes it to the MAC, and the MAC layer and the data link layer adds a physical address called the MAC address. Then, as long as you are within one network, LAN, local area network, the physical address and IP address are not gonna change, they are the same. Once you get out of the network, you want to communicate or you want to talk to a computer from a different network, then the IP address will, the physical address here will get updated with the physical address of the computer that will receive this data and handle it, or the node that will handle it. And this process continues until you reach the destination. So as you can see, the physical address gets updated here once you go into a new LAN. And whenever you have a jump from one LAN to another, you have to have a router. Router, because without router you cannot do this. Router is responsible for directing and finding the shortest path that the packet should travel through, so that the packet can reach your receiver with the best quality of service and shortest distance and lowest delay. So these are the things related to the IP addressing and MAC